Here's a hint. If you come out with a positive number, you're wrong. Casino is not losing money. Casinos are pretty good at money. What'd you get? You win this and win this. So you're dividing them. That's easier. It's tie easier. I think that's what you're missing. So let me show you how I would do it. Let's get to talk through it and think through logical different ways to approach it. But there is a formula. So this is expected value, the average. So what you do for that, you take the probability of the outcome, and then you multiply it by the outcome, plus the probability of the next outcome, and you multiply it by the outcome. And you just kind of keep going until you're done. So I'm going to look at it like I'm playing once. Like I'm just going to do $10. And then at the end, I'm going to multiply it by 1,000 to represent that I played 1,000 times. But if I'm just playing once, I think the simplest way to do this is to say I got a 42% chance that this class has happened. This happened like at the end of the month. December. Was that in here? My marker just stopped working. Alright, never mind. I got a 42% chance of winning $10. So that's the probability of that outcome times that result. Times that outcome. Plus, I've got a 0.08 chance of tying, which is $0. Plus, I've got a 50% chance of losing, which is -10. So that's like that's the formula I'm trying to teach you today. It's just that. Of course, go practice that in different ways. That's the idea. Probability times outcome, probability times that outcome, that probability times that outcome. If I multiply those together, I believe I get -0.8. I don't know if anyone did it this way. So on average, every time you play, you're expected to lose 80 cents. This is kind of weird for some people because could you play one time and lose 80 cents? Is that a possible outcome for playing once? It's not. You're either going to win 10, lose 10, or get 0. Some people get all tripped up. Well, how can that be the average? The idea is if you played it over and over and over again, over the long run, you'll lose an average of 80 cents per time. So no, you can't get that on any individual event, but over the long run, that's the average. So if I were to play this 1,000 times, Casino would be thrilled. So it would be -800 is what you would get. Am I have -800? Okay. Questions on what I'm doing there? So let me just change the question a little bit. Oh, start looking at that worksheet. If it doesn't work, yeah. Is it an expo?
Yeah, it's an expo.
I know. That was really angry. try that one. So same idea. I just call this a random card game. You want right now? You want to? No, I want to. Yeah, just gotta spray it. You have the rest of them? Yeah, a couple practices, but not a couple. No games, tournaments, are they? Most of them are You wrestle on the break beer? Just the practice. Yeah. Yes, I know it's good. Yes. Yeah. Alright. So this would be another way to look at this. Some of you will find this helpful, some of you will find this like, that seems useless, why am I doing that? I'm going to show it either way. Because you'll see this like presented this way too on Khan or on AP questions. So X is going to be like the amount of money you win. This is the probability of X. So this would be like I win $100 5% of the time. This would be I win $20 25% of the time. I win $0 20% of the time. I lose $10 50% of the time. So that's the same. It's just presented a different way in a chart instead of words. And then you multiply this, these two, these two, these two, these two. You just add them all up. So if I'm writing out the formula, 0.05 times 100 plus 0.25 times 20 plus 0.2 times 0 plus 0.5 times negative 10. What do we get? We get today, right? 5. Like that right there comes out to 5. So if I play it 100 times, what do I expect to happen? I would expect on average to win $500. So could I win $5 on any individual game? No. If I play it over and over again on average, that's what I expect to happen. How many had 5 or 500 here? Questions on that? All right, let's start looking at the worksheet I gave you. So the front and back of that are similar. One side, and then you do the other side. So these both look the same almost. Like there's a front and a back, but it's kind of hard to tell. I'm gonna start on this side where it's got the formula on top. If you look at the other side, it doesn't have the formula on top. This is what I would call like the back. I'm gonna do the front, and then have you guys do the back. That's what we're going for. We'll do the front together. Number 1 is really similar to the ones we just did. to set up like a little chart, you can. I don't know if you need to or not. Again, some people will find it helpful, some people will find it not so much, but $200 is a 0.01 chance. $50 there's a 0.1 chance. And then I just said the rest of the time you win nothing. So remember the probabilities have to add to 100, right? So we got 11% so far. So this must be 0.89. Or if you're skipping past that, you probably just jump into 0.01 times 200 plus 0.1 times 50 plus 0.89 times 0. 7. Okay, for number 1. Skip 2. The 2 and 5 are the beasts here. Try 3. We'll do 2. Did you get something different? You got something different? That's from this, I thought. That actually makes way more sense. Am I get what I got, or am I alone here? Okay. So how many got that right? Or how many got negative 0.75 and then times? Yes, everybody. Okay. So negative 0.75 and then times 50. So it's like negative 37.5. You play 50 times. I had the formula set up right. I just don't know how to type it in. 4 is similar. It's just fractions that are decimals. So they got this wheel with 38 spots. And if it were 18 red, 18 black, it'd be fair. It'd be like a 50-50 game. If you play it a billion times, you'd expect to come out even. But then what they do is they give you these 2 green slots also, and if it lands green, you lose. So it's not fair anymore. You have a higher probability of losing than you have of winning. And it's a very slight amount, but it's enough that the more you play, just that little edge that they have just adds up and adds up and adds up. And you just can't beat the math. You're not going to win this game. Casinos know the math. They give themselves a slight edge. They put shiny lights and fun things and make you want to play, and they rake in the dough. So, if I were making like a table here, I win $10, 18 out of 38 times. If it lands black or green, I lose $10. Well, that's 20 out of 38. So again, if those were even, I gotta take this. I'm sorry. Hello. Hello. All right, thanks. Bye. Hot water heater broke over break. Well, like 2 days ago, so it wasn't too bad. It started leaking and it shut off. It was, I don't know if you know anything about it, but it's a flammable vapor sensor. I got that signal and then I had someone come out and it started leaking. It was like, it's 10 years old, so it was pretty much. But I hadn't showered in like 4 days. So yesterday I had to. Oh my god, it was freezing. You stuck? Really? Yeah, it was rough. Alright, so 10 times 18 out of 38 plus negative 10 times 20 out of 38. You guys see how I'm setting it up? Does that make sense what I'm doing? So that is negative 0.526. So on average, again, you can't lose 52 cents on any single time you play. But on average, over the long run, if you play a billion times, you lose that much per hand. Questions on 1, 3, or 4, because those are kind of the most straightforward. Before we get into 2 or 5. All right, let's do 2 next. So this isn't that much tougher, but there's just 2 different ways to look at it, so maybe it's just tougher to explain. Kind of gets into Peter what you were saying, like do I count it as profit or do I subtract the 3 at the beginning? So you're paying $3 to play this game. It's split into 4. You're doing a wheel that's split into 4 equal parts. So right away I can go 0.25, 0.25, 0.25, 0.25. And so some people completely ignore that $3 to play the game. They just figure out how much it would cost if I weren't paying anything. At the ends, they subtract 3. Some people will figure out so let's do it that way first, and then I'll talk about like the other. So forget the fact that we're paying. Like I'll basically cross that out because we're going to take care of it all at the end. So one part results in you winning $10. So then you can just put a 10 there. Another part results in you winning $5. Another part results in you getting your money back. So what's your profit in that situation? 0. So you're putting the profit up here. And then another one means you have to give the person $5. So that's a negative 5. And then we're going to be throwing the fact that, oh yeah, by the way, we paid $3 just to even play this game. And we're going to figure that out. The other way to do it is to throw in the -3 in every single situation. So if I paid $3 to play and I won $10, I really only profited 7. You know what I'm saying? And I don't care which way you think about it. And it might be more confusing than I'm showing you both. I don't know, but I want to show both options. So this way, you're not worried about the -3 at all to the very end. This way, you're putting the -3 in each slot. second part results in you winning 5. Well, you paid 3, so what's your profit? It's 2. Another part results in you getting your money back. Well, you paid 3, so if you get your money back, that's minus 3. Wait, that doesn't make sense. This should be, yeah, I screwed this up. This should be a 3. Going way back over here. If you get your money back, they give you $3. And then over here, if you get your money back, what's your overall profit if you got your money back? It's $0. I screwed that up. And then in this one, you got to give them another $5. We already gave them 3, so that's minus 8. So either one of those you're going to calculate, and they will come out the same. It just depends on whether you're putting the $3, like what you're doing with the money that you paid to play. Can I go over either one of these again? I kind of screwed them up. How many like this way, where you just don't worry about the fact that you paid the $3 at all? How many of you made this make more sense, where you put the $3 in each one? Okay. So either way, you should get the same thing. So you get 0.25 either way. Question on that one. You got 0.25? We good on that one before I go on to number 5? So read through 5. You guys alright? Molly? Connor, you good? So 5 messes people up. Hopefully it doesn't, but it tends to. So there's 2 situations. You got 2 doctors. I got the crappy doctor. He's cheap. He's $20. They only work 60% of the time. So you're taking a risk if you go there. I got a second doctor that's more expensive at $60, but I know he's going to cure me. If I go to the first one and he cures me, I'm done. I'm not going to go get cured again, right? If I go to the first one and he doesn't cure me, now I'm stuck and I have to go to the second one. Does that make sense? So what in this situation, it's not like which is better. It's just saying, because that gets into like personal choice. Am I willing to take the risk for the money? Like that's not a math problem. That's more of like a personal finance problem. This is saying, if I start with the first doctor, what's the expected amount that it will cost me? So if I start with the first doctor, what's the probability that I'm done? That I'm cured and I can stop going to doctors? 60%? And how much do I pay if that's the result? $20. Here's where people fall off. So what's the probability that I have to keep going, that I'm not done, that I have to go see another doctor? 0.4. If that happens, how much money will I have spent in total? $80. So the very common mistake is you put 60. Forgetting, but it's the total amount that it costs. So this has to be 80 because you've already paid that 20. So there's a 40% chance that you have to pay the 20 and the 60, giving you a total of 80. Does that seem Okay? So then it's just a normal product from there. Then you just go 0.6 times 20 plus 0.4 times 80. So the expected cost of this method would be $44. What's the risk? You might come out cheaper, you might come out more expensive. So the back of this worksheet is basically the front with different numbers. So before I get you going on that, are there any questions on the front I can like go through again? So I'll go through the back and do it on my workout, so you can check them and give you time to go through these. How many of you guys like this table? Does that help? Okay. answers and the work. If you're not understanding something, where are you getting this from? How do you get this? Your test corrections, I know they still have to exist. Where you want them to exist. Not everyone's taking it yet, so can't give the test back yet. Person is getting a different test, so they're not super different, so I don't want to give it back yet. That sounds really that great. I understand there's not much I can do. What? That's very true. As far as exams, we talked about this on the right. So we'll be finished on the chapter probably like end of next week.